Now you know that the basic equation that we have is tau is I alpha. But remember that this is torque about the axis of rotation, is I about the axis of rotation into alpha. Later we will do this with the center of mass even when it is not really the axis of rotation. Like if I took this object and I threw it like that, then I can do it about this even though the axis is moving. It's not really an axis of rotation that way. It is rotating about the center of mass plus translation. Here I am talking about fixed axis. So when I am talking about A, I am talking about fixed axis. So we are going to use this. Okay. First question, very simple. In fact, I am going to give you two questions. In the very first question, what we are going to do is we are going to look at this object. What is this? A rod. I am going to leave this rod, but I am going to pivot it here. What does pivot mean? Pivot means it can rotate about this point. Like for example, suppose I hold it, but I am not holding it very tightly. Let's say I put a small thing about which it can rotate. It can do this. Correct? Now what I want you to do is I take the same rod, and do you know the moment of inertia of this rod? About this axis. Because you see here, I about this axis. So what should I do? I about this axis is m L square by 3. Moment of inertia about the end point. So this is something that you should remember. About this axis like this, the answer is ml square by 3. So I have a rod, thin rod. Okay. Now this rod has mass m and it has length L, both given. Pivoted here, pivot. Released from horizontal position. Okay. What do you think the weight is going to act? Its weight is going to act here. Correct? But there are also going to be other forces that are there because the pivot will exert certain forces. So here are the following questions. 1. Find alpha. Whose alpha? Alpha for the rod. But don't I have to say alpha of this point, that point? No. For alpha, you don't need to say whose alpha. You say alpha for the rod because the whole rod has the same angular acceleration, same angular velocity, same angular turn, so angular displacement. But this point on the rod and that point on the rod will have different accelerations. So when I come to acceleration, unfortunately, I have to say, I can't just say find A. This you can't say. Please notice. Alpha, I am not writing anything because alpha belongs to the entire object. The whole object, like we take this thing and rotate it, the entire object is rotating with the same alpha. About this, same. But each point has a different velocity and a different acceleration. So find acceleration of the center of mass. First question, alpha. Second question, find acceleration of the center of mass. Third question, find force by pivot. This is a pivot. How much force does a pivot exert on the rod? Angular acceleration is the rate at which the angle is turning. That is the angular velocity. The rate at which the angular velocity is changing is angular acceleration. But if you look at acceleration of the center of mass is here. So this fellow has an acceleration. And I am asking you this at the horizontal. At horizontal position, find the following. It is released from horizontal position. At this time, find the following. It was released from rest. Okay. So the question is very simple. So at this time, find what the alpha is, what the angular acceleration is, what is the linear acceleration of the center of mass. So the linear acceleration, well, it will be like that. Okay. And what is the force exerted by the pivot. So come on, 2 more minutes. So let us start solving this question. First, if I think of this as the rod, then I am holding it at the pivot. The pivot will exert a force. Which direction, we will worry about that little later. But whatever direction, let's assume that it was this direction or that direction or that direction, the force passes through the pivot. Correct? So if I take the torque about the pivot, let's call this pivot P, torque about the pivot, this force F of the pivot is not going to produce a torque because the force is through the pivot. Force into perpendicular distance, right? So for example, somebody was asking this question about what is the difference between force and torque, and I think Sudesh asked the question, and I think somebody else explained it very beautifully. Anirudh has explained it very nicely, right? So if you see this, if this is my pivot, if this was a door, and I'm pushing with a force, let us say F, it is going to turn. But if I had used the same force here, it is going to take a lot of effort for it to turn. The turning effect of the force is R times F, but actually we should be saying R times F perpendicular to R. This is R. F is perpendicular. Because if the force has a component like that, right? So if the force look like that, it has a component like this and a component like this. This is the parallel force, does not produce a torque. If you resolve this force as F parallel and F perpendicular, only F perpendicular produces a torque, right? This produces a torque. This pulls it, it doesn't produce a torque. So the torque is R into F perpendicular. But the problem with this whole thing is, if I look at this point and the force is passing through this point, what is the distance of the point? 0. Because the distance to the force is 0. So if you take the distance to the force, you can by the way write the torque as R into F perpendicular or R perpendicular into F or R cross F. Where is the R? R is here. So what is R? R is 0. So what is 0 cross F? 0. 0 cross F, it doesn't matter what it is. So this fellow, this one's torque is 0. Plus this is 0 due to Fp, force at the pivot. Then there is a force here. How much is the force? Gravitational force, mg. Now mg is acting at the center of mass, which is basically, it's a uniform rod, so it is at a length of L by 2. So the torque due to mg, mg into L by 2. So this is mg into L by 2. In which direction? This direction. This direction means into the board. So this whole thing is into the board. So for into the board, you will use the symbol cross because it's like you're shooting an arrow into the board. The back of the arrow is the cross. If it is coming out of the board, we will use a dot. So this is into the board. Okay, right. So if I use this, then I know my torque is mg L by 2. If my torque is mg L by 2, tau is I alpha. So alpha is torque by I. But what is I? I about this, you already know the formula, ml square by 3. So I can write alpha is tau by I in this case. Torque is mg, or I'll just write the equation straight away. I won't use this right now. It's easy to use both. So I'll just write mg L by 2 for I m L square by 3 times alpha. So you can cancel m, you can cancel an L, and then you can bring this up there and bring the L down. So alpha is 3g by 2L. The L comes down, 3g by 2L. So for the first part, alpha, the answer is 3g by 2L. So I hope that is clear. Whose alpha is this? Is it this point's alpha? Yes. Is it this point's alpha? Yes. This point's alpha, this point's, it's everybody's alpha. It is the alpha for the whole rod. Okay. The whole rod has the same alpha. Why does the whole rod have the same alpha? If you take this, if you look at this fellow rotating, then this has a radius. Think about that radius. Now if I turn this line, how much would it have turned by? So let us take some straw. or better to take this, right? So if I look at this and I look at that, right? So I have taken two vectors, the red one and the blue one. So if I turn it, the red one turns by an angle theta from original position. So imagine it was like this, it turned like that, it has turned by some angle theta. Blue has also turned by the same angle theta. Everybody has turned by the same angle theta. That is not the only reason. That is one important reason. The whole object turns by the same angle is very simple. There is something much more interesting that we will come back to at a later point, so next time when we look at it. A says C is turning at theta or turning by theta. A says B is turning by theta. B is saying C is turning by theta. That's something you should think about. What does B say about C? It will turn out that that is also theta. The whole object is turning with theta with respect to any point on the object. Okay? So that I am not explaining right now, but that's a given statement. Just think about that statement. It's a very interesting point and that we will use later. At this point I don't need it. I just need to know everybody has the same alpha with respect to the axis. That's all. But it is not with respect to the axis, with respect to anything. Let us go to the acceleration of the center of mass. You know that this point's acceleration must be r times alpha. Remember, alpha was a by r. Everything in motion divide by r. Linear, multiply the angular quantities by r. So a must be r alpha for a rigid body. For a rigid body, let me repeat, rigid body. This is a rigid body. So this guy's acceleration of the center of mass must be the distance of the center of mass L by 2 into alpha. But what is alpha? 3g by 2L. So 3g by 2L into L by 2. So it is 3g by 4. Acceleration of the center of mass 3g by 4. Notice acceleration comes in the units of meters per second square. Whereas if you look at alpha, it is meters per second square by L, which is meters. So it is just per second square. It is actually radians per second square. This is alpha will always have g by L kind of term, whereas just linear acceleration will have 3g by 4. So I hope that is clear. Okay. Yes.
A doubt. How do you find the torque as mgl by 2 without using integration? Did you use the integration fact?
I did not use any integration. So I'm going to make a simple statement. How do you prove this statement? Yeah, you need to probably use integration, right? If I take a body, you start off by saying that mg, m1g, m2g, m3g, m4g, all of that keeps acting, right? It acts at the center of mass. mg acts at the center of mass. Center of gravity, which is the same as the center of mass. Okay. So if I don't worry about each of the individual m1, m2, m3, m4, if you assume that the entire things, it's like a concentrated point, center of mass. Now, if you ask me, how do I know center of mass? Well, that's a separate topic that we have done earlier probably, when some of you at least who have done it in the online course. Center of mass calculations we have done earlier. Okay, so total mass m1g plus m2g, m3g, m4g, if you take all this, the torque of all this about the center of mass and the torque of this about the center of mass is the same. About any other point also, if you want the torque of these fellows, it will be the same as the torque of the mg being acting at the center of mass. So we start off with a very simple idea. The entire mass is as if it is concentrated at the center of mass. Gravitational force is as if it is concentrated at the center of mass. This is not valid in general. It is valid for uniform gravitational field. So for example, on the surface of the earth, it is valid because g is the same for every place, and therefore for you're talking about like reasonable heights. So when you're talking about mg, you do assume that the force is acting at the center. If you want to be more complicated, you can say at each point let us do dmg, and you can take all the torques together and add it up. But I think that's like an overkill for a problem like this. This is a very simple question. You can do that when actually things are changing. Okay. For example, if I had a different case where it was not a uniform rod, then you won't know that the center of mass is at L by 2, because the center of mass here is at L by 2. If it is non-uniform, it may be somewhere here and there. By the way, if it is non-uniform, I have more complexity because this won't be true. So you'll have to do a lot more difficulty, you have to do it in calculating, you have to do a lot of other things. It's a very simple question here. So let us focus on this. Okay. Now let us go to the next one. How do I find the force on the pivot? So let us think about that. Just to kind of clear up things, let me put, this is mass m. Let us see. Now, we know F equals ma. Now that was for a single object. For a system of particles, you say net external force is mass of the whole system into acceleration of the center of mass. So hopefully you have learned this in as part of your system of particles statement. Very simple thing, just simply because the internal forces cancel out. It's a vector. So I should say acceleration vector, force vector. Now if I take this, I'm going to just erase this so I get some space. Let us look at this statement. This tells you mass into acceleration of center of mass. But acceleration of center of mass, this guy's acceleration is downwards. What is this fellow's component in this direction? What is the component of acceleration like that? 0. Why? Acceleration of center of mass. Acceleration of center of mass only has a component vertically in this position. Why? Because it has no velocity. I have left it from 0, rest. Okay, that last point sometimes you might have to think hard. If it has a velocity, I'll have to worry about mv square by r. No, I don't have to. Okay, so acceleration of center of mass is vertical, and that vertical component of acceleration you already know is 3g by 4. But since the acceleration of center of mass is horizontal component of the acceleration is 0, it tells us that the net external force horizontally must be 0. But there are only two forces. This force mg, and then there may be a force like this and a force like this. So I'm going to call it Fy and Fx at the pivot. But you see that Fx is the only horizontal force. Since the acceleration is 0, Fx is 0. Because external force, the only horizontal external force is Fx. So the pivot does not exert a horizontal external force. I want you to keep that in mind. But it does exert a vertical external force. Can you say Fy is equal to mg? Is Fy equal to mg? No, no, no. Okay. If I was holding this rod, Fy is equal to mg because this rod isn't moving down. But now the rod is moving. It has an acceleration down, so Fy is not equal to mg. How much is Fy? Well, downwards, right? I'm going to take that downwards. Mg minus Fy. Mg is this force minus Fy, because Fx anyway I know is 0. There's only two forces. Net force is mg minus Fy downwards. Mass into acceleration of center of mass. Acceleration of center of mass is downwards 3g by 4. So 3g by 4. So just flip this around. So Fy is mg minus 3 by 4 mg. How much is that? Mg by 4. So, and there is no Fx. Therefore, force by the pivot is equal to mg by 4. Please notice it is not mg. It is mg by 4. It is not 0. It is not mg. It is mg by 4. Okay, I hope this is clear. How many people understood this? Can you quickly check if people understood this? How many people got this mg by 4 also? Very good. Some of you have actually got this. It's excellent. 5 people have got this. Very good. So now let us look at, I hope everybody has understood now what to do. Let us come to a slightly different question in this. What I'm going to do is, remember that rod. I'm going to do the same thing, except now the rod is like this. Okay. So what I'll do is I'll give you 2 questions. So we can do this in parallel. So you can see the difference. One is I have a rod, and instead of pivoting it here, I am pivoting it there. Okay, so where is the there? The there is here. L by 4. What is this length? 3L by 4. It's a uniform rod. Uniform horizontal rod. At rest. Is the at rest important? Very, very important. For one part of the question at least, it's very important. This is my pivot. Center of mass is not here. Center of mass is as always at the middle. Mass of this rod, m. What is the question I'm going to ask? Same old questions. First, find alpha. 2, find acceleration of the center of mass. 3, find force by pivot. So this is one question. And I'm going to ask you the same question, not exactly like this. I'll make it slightly easier. And you have already done the earlier question, so you know what I'm talking about now. Except this rod is no longer horizontal. It's like this. I'm releasing it like this. Or it came down like this. But if it came down like this, the third part of the question will have slight complication. So we will just assume that I was releasing it like this. So this is my pivot. Okay, mass m, length L, okay, this angle is 30 degrees. Angle with the vertical 30 degrees. This is how it's going to rotate. It's pivoted like that, so it can rotate this way. So this is also going to rotate like this. Right now it is not rotating, it's at rest. This is also at rest. Mass is m, length of the rod is L. What is the question? Same questions. Find alpha, find acceleration of center of mass, and third part, find force on pivot. Force by pivot. Force on pivot will be opposite of the force by pivot because it's action reaction. Okay, come on, quick, 2-3 minutes for each question. But let us first look at this question. So if I see this question, this object is rotating about point P. Okay, there are two ways to calculate its moment of inertia. One is to use parallel axis theorem. So I can do that. I can look at where the center of mass is. Remember, parallel axis is always moment of inertia about axis is moment of inertia about center of mass plus ma square. Okay, the distance, it's always from center of mass. So center of mass must be at a distance of, if this whole thing is L, this must be L by 2. This is already L by 4. So this distance must be L by 4. This must be L by 4. So that whole thing is 3L by 4 minus this. So this is L by 2. Right? So this is my center of mass. This is where mg acts. I'll just mark it as well so that we can see that that is where mg acts. Okay, so this is the center of mass. What is I about the center of mass? What is the formula for that? M L square by 12. Or in this case, I about P. Because P is the pivot, which is the point I'm going to take. M L square by 12 plus mass into this distance square, M into L by 4 whole square. L by 4 whole square is L square by 16. If I total these two, you can add this up. I'll get ml square, multiply this by, this is 4 into 3, that is 4 into 4. So 4 into 3, I multiply this by another 4, so 4, multiply this by 3, multiply that by 3. So you see I have made it 4 by 48, 3 by 48, add it up, you will get 7 by 48. So the answer is 7 by 48 ml square is moment of inertia about P. Okay, so it's a good thing to write it down separately. Moment of inertia about P is m. So 7 by 48 ml square. Always calculate the moment of inertia very quickly, first thing, because you're going to use it a lot. Okay, so this hopefully is clear. We could have also done that by saying I have m by 3m by 4 and it's a rod. And I have m by 4 and it's another rod. So you can add that fellow's moment of inertia about this edge, this fellow's moment of inertia about this edge, and add it up, you will get the same answer. Okay, so you don't have to use this. But I have just used parallel axis theorem. I'm going to erase this because I want some space. So Is that clear? Moment of inertia 7 by 48 ml square. Now I am going to use torque is equal to I alpha. So alpha is torque by I. What is the torque? Torque about P. There are two kinds of forces we should think about. Force passing through pivot, which may have a y component and x component, and you will have an mg. But whatever the force at the pivot is, that force torque is 0. Only torque we are going to get is because of this fellow, and what is the distance? L by 4. So torque is mg into L by 4. Force into perpendicular distance or perpendicular component of force, and look at this force. This force is perpendicular to that. So this angle is 90 degrees, so sine 90. R into F into sine of the angle between them, R cross F, or perpendicular F, it is already perpendicular, so mg into R, L by 4. So this is the torque divided by I, which is 7 by 48 ml square. I can cancel out the ml here, and you can see you will get a G by L. Because I have cancelled the ml, I have cancelled one ml, you have a G there and you have an L here. You have 1 by 4, 1 by 7 by 48 is 48 by 7. So 48 by 7, and then there is a 1 by 4. So this is going to cancel out 12G by 7L. So alpha is 12G by 7L. The only difference in this case is the center of mass is at a slightly different place, and the moment of inertia is different. That's it, nothing else. So easy problem. This is slightly more complicated. We'll see that soon. What is the acceleration of the center of mass? Well, look at this. This is a rigid body. So if I take this rigid body and I tell you that I'm holding it here and it's going to rotate, this guy's acceleration is R, this R times alpha. Correct? So acceleration is going to be L by 4 times alpha, because this distance is L by 4. Alpha is 12G by 7, so L by 4 into 12G by 7L. So if I cancel this L out, 3, I get 3G by 7, which is different from what we had got earlier, right? So this acceleration is 3G by 7. Obviously, because it's a different point, so you have to use alpha to find acceleration of center of mass. You can't find the acceleration of center of mass directly. Now comes the interesting part, which is the force on the pivot. Now pivot force you can think of as having two components, like before I told you, Fx and Fy. This is Fy, this is Fx. What is Fx? Mass into acceleration in the horizontal direction. Mass into acceleration of center of mass in the x direction. But wait a minute, center of mass has only an acceleration in the y direction. There is no acceleration in the x direction. So this is basically 0. What about Fy? You can't say Fy because you have two forces in the y direction. So let me start off by writing Fy, but it's downwards, no acceleration. So it's a good idea to write mg minus Fy. You could have also written Fy minus mg. For a change, what I'll do is I'll write Fy minus mg. What have I done when I write Fy minus mg? I want to look at acceleration upwards. But you see, acceleration of center of mass is 3g by 7 downwards. So I should take it as minus 3g by 7. So this is equal to mass into minus 3g by 7. I hope this is not confusing. If I had used Fy minus mg, you must say mass into acceleration in the direction of force. Newton's law says net force in the direction of the net force, you must have the acceleration. So acceleration direction and net force direction must match. Here I found Fy minus mg means upward direction. So this must also be upwards. Usually what I do is I'll start with MA first, because this will then tell you, oh, center of mass into downwards 3g by 7. So let us find the net force downwards. So the same thing, I would have written mg minus Fy. Either way, you will find Fy is mg minus 3mg by 7. 1 minus 3 by 7 is 4 by 7. So therefore 4mg by 7. So pivot force is 4mg by 7. Is that okay? Clear? Now if you notice, this question is very similar to the previous question because nothing much really changed. This question is not like the previous question, and because I'll just tell you the main tricks. If you see, the center of mass is here. Moment of inertia is very simple. ml square by 3. Did it change from the case it was like this? No, because whenever it's rotating, moment of inertia about this axis. This is not the axis, by the way. This is a vertical statement. The axis is this. Okay, like that. So axis is just a line. The rotation I'm saying is that way. Okay. Now, for this axis, I is ml square by 3. Whether you keep it this way, keep it this way, keep it this way, doesn't matter. So I has not changed. Still the same. mg has not changed. Still the same. Why will this answer be different then? Because you will not write mg into L by 2. You need to write force into perpendicular distance. Or you have to take the component of the force. You have to either resolve this force like this and like this, and this will not produce any torque. Only this will produce a torque. You can see that if I pull it like this, that it will make it rotate about this point. If I pull it like this, this force is not going to make this fellow rotate. This force will make it rotate. So this force is not going to make it rotate. Only a component of this force is going to make it rotate. And that's important. Okay. So if this angle is 30 degrees, then you have to remember this angle is 30 degrees. mg cos 30, mg cos 30 is this component. Will it rotate? No. mg sin 30, will it rotate? Yes. How much is that? Sin 30 is half, so this is mg by 2. So in this case, the torque about P, you don't have to worry about forces passing through P because their torque is 0. Like we have seen this earlier, right? But this fellow has a torque. The torque is mg by 2 into L by 2. mg by 2 into L by 2. And many times what happens is people forget this. They will write mg into L by 2, but that's not valid because the force is like this. You cannot take this distance, you have to take that distance. Remember, torque is R cross F, which is R perpendicular into F. So if I took this force, I cannot take this R, I must take the perpendicular distance. Or you can rewrite this as R, keep R as it is, and only take the component of the force perpendicular. That's what I have done. Instead of taking this distance, which also would have been fine, L by 2 cos 30, L by 2 sin 30. I could have taken L by 2 sin 30, you would have got the same answer. But what I'm doing is, I'm saying the force itself, I will take it this way and that way. I'll take this component of the force, and then I will say, this component of the force produces the torque. This component of the force does not produce the torque. Clear? So the torque is mg L by 4. In fact, the torque is very much like this torque. But the moment of inertia is different. So alpha calculation is very easy because alpha can just be torque by I. What is the torque? mg L by 4. And what is I? ml square by 3. So one ml can cancel out. So this just simply goes up there. So 3 by ml. So you will end up with 3g by 4l. Simple. Now comes the tricky part. Acceleration is also not a complication. That's also very simple. Why is the acceleration simple? Because if you take the acceleration of the center of mass, this is the center of mass. You want acceleration of center of mass. It is L by 2 times alpha. Is it okay? Acceleration of the center of mass is distance of the center of mass, correct, which is L by 2, and it's rotating. So if you take this guy and this fellow is rotating, this point has an acceleration which is how much? L by 2 times alpha. So L by 2 times alpha. Do you know the alpha? 3g by 4l. So L by 2 into 3g by 4l. 3g by 8. So acceleration of center of mass is 3g by 8. It is at rest. It is at rest. So that is important. Where have I used the fact it is at rest? I have not yet used it. I am going to. Let us take this direction as I cap, x direction. That direction, j cap. Now most people are going to get the last question wrong. It is just F equals ma. Why will you get it wrong? I am going to give you 2 minutes to try this out. Okay? Just 2 more minutes. Please, I have already solved half of the question. I want you to take a little bit of time and find the force by the pivot on the rod. Force by the pivot on the rod. 2 minutes more. Come on, quick. So if you see this, what is interesting is if you want the force on the pivot, remember F equals ma. But F equals ma, Fx is equal to max, Fy is equal to may, net. So I should put net force. Now the point is, at the pivot, will you have a y-axis direction force? Yes, because though this is mg, right, acceleration is in this direction. This acceleration is in this direction. Why? Why is the acceleration in that direction? Because when you take this object and say that this is going to rotate, at this point, its acceleration is like this. If it was at rest, why does the rest come in picture? Otherwise, it has an acceleration of two kinds. It will have a centripetal acceleration, mv square by r, and it will have a tangential acceleration. Right now, we are only talking about the tangential acceleration because it's at rest. So, mv square by r, v is 0. If I had a v, then I'll have to take that also into account. Now, this acceleration has a vertical component and it has a horizontal component. So, there is going to be an fx this way. Why that way? Because you see, this acceleration has a component like this. So, that means there must be a force like that. And it has a component like that, which is fy. Let us write the equation carefully. This is the acceleration, I know it's 3g by 8. But if you take this, I have to resolve it horizontally and vertically. If this angle is 30, this angle is 60. A cos 60 is the vertical component. So the vertical component, so if you took at A center of mass, vertical component is A cos 60. So 3g by 8, cos 60 is half. So you get 3g by 16. Horizontal component, if I call that I cap, it's actually minus. Okay, it's in this direction. I just want the magnitude. It is A sin 60, which is this into root 3 by 2. So I'll get 3 root 3 by 16 g. Because 3 by 8 g into root 3 by 2 is 3 root 3 g by 2 into 8, 16. So this is 16. Right? Now let us write Newton's laws. Fx is easy. So let us write Fx. Fx is very simple. Why Fx is very simple? I am not worried about these components. I will only look at mg. So I know it's a little messy. So think about it carefully. So let me in fact clear up this space also a little more. So you can then see the diagram. So here is the diagram. I will just redraw the diagram. There is a Fx like this, Fy like that, and there is an mg. And the acceleration is like this, which I have resolved into two parts, Ax and Ay. Ax is 3 root 3 g by 16 minus direction, and Ay is also in minus direction, 3g by 16. So we then have to write just acceleration, mass into acceleration of the center of mass. This is all for the center of mass. So since this is for the center of mass, Fx is equal to mass times this. So m into 3 root 3 g by 16, right? So mg 3 root 3 by 16. In this direction, please keep that in mind. Fy, what is Fy? So you can write Fy, but before we start Fy, it will be a good idea to start with this, right? So mg minus Fy, mg minus Fy should be ma. m vertical A. What is the vertical A? You have already calculated it here. 3g by 16. Downwards, downwards, minus, because this is upwards. I have taken downwards as positive here. Usually I should take the upwards as positive. Given final answer, I will write it in upwards positive. So what is Fy? Take it to this side, take this to this side. You will get mg minus 3 by 16. So mg minus 3 by 16 mg. So let us write that down. Mg minus 3 by 16 mg. How much is that? 13 by 16 mg. 13 by 16 mg. Notice this is not the full force. You have two components to the force. So if I were to write force as a vector, force is a vector, pivot force. The pivot force has this component and that component. It will have an fx, but remember it's showing it in this direction. I have taken it in this direction. So therefore my answer should be minus 3 root 3 by 16. I will write separately, mg by 16 separately. Minus 3 root 3 I cap. Minus 3 root 3 I cap. Correct? And I have an Fy which is positive. Fy is positive because it's pointing up. J cap. Even here, I use the minus sign here already. But I have taken Fy the way I have taken it. So Fy is plus 13 by 16. So plus 13 J cap. So this is our force answer. But we want to write the magnitude of the force. Suppose I want the magnitude of the force. Then force magnitude will be this square plus that square root of. So we can write that as root of 3 root 3 square. What is 3 root 3 square? 9 into 3, 27. Plus 13 square, which is 169. Mg by 16 will be as it is, mg by 16. So what is this? If I add this up, 170, 190, 196. So root of 196 by 16. So is that a perfect square? I don't think so. 14 square is 196, right? So yeah, so this is 14 by 16 mg. So if I cancel this out, this is going to give me what? 7, and this is going to give us 8. So therefore, force by the pivot magnitude is 7 mg by 8. Now, if you had forgotten that there is a component of acceleration, you just wrote mg minus Fy minus mg is equal to ma, and you wrote ma as it is, you would have got a very different answer. But this is the answer that we are looking for. So I hope this is clear. Okay.